So this is example 2. You see in this example, we have to find the forces in other members. And it is given that two forces are acting at point B and at point D. You see the force which is acting at point B is P1 force and it is equal to 10 kilonewton force. And it is acting vertically downward. And similarly at point D, a force P2 is acting which is equal to 8 kilonewton. And it is also acting vertically downward. And you see that at point A and G, the truss is connected with the ground or the wall by using a pinch joint. So two reaction forces are acting, which are these, and these are other forces that we have to find. So uh, first of all, I am going to start with point D. So these are the forces that are acting at the members. You see the angle between these two members is about 63 degrees. And when we apply that, the sum of forces in y direction is equal to 0. So we get minus 8 kilonewton force, which is basically the force P2. Plus we get FDE force with its vertical component sine, which makes an angle of about 63 degrees. So after solving it, we get the force in the member DP, which DE, which is equal to 9 kilometer. And you see this member is in tension. And when I apply that sum of forces in x direction is equal to 0, so I get minus F DC force and minus F DE force with its horizontal component force with angle 63. So I get force in the member DC, which is equal to minus 4 kilonewton. And you see that this member is in compression. Um, so when I take the joint C, so three members are connected with point C, and these are the forces that are acting at the members. So getting to the first equation, we have FCD force negative FBC force because these two forces are acting in opposite direction. So we get the force in a member BC, which is equal to minus 4 kilonewton. And you see this member is in compression. And when we get the force in y directions, so we get force EC, which is equal to 0 kilonewton. And when we take the joint E, you see that four members are connected with point E. So these are the forces that are acting at these members. So the angle that these members are making is basically 45 degree, and it is the angle between the members FE and the member EB, and member ED is making an angle of about 63 degree. So um, forces in y direction is given as minus FBE force with its vertical component sine and angle of 45, negative force in the member AC and negative force in the member DE with its vertical component sine with angle 63. So we get force in the member BE, which is equal to minus 11.4 kilonewton. You see this member is in compression. And when we take the force in x direction or force in x direction, so we get negative force in member F, negative force in member B, with horizontal component, plus force in member DE with horizontal component. And you see that we get force EF, which is equal to 12 kilonewton. And you see this member is in tension. And when we take the joint B, you see four members are connecting and a vertically downward force is acting, which is P1. So when we resolve the forces that are acting at the members, so we get these forces and we get an angle of about 45 degrees between the members. So when we apply that, the forces in y direction, so we get positive force in member FB and positive force in member B with vertical component sine and angle 45 and a negative decelerated force. So we get force in member FB, which is equal to 18 kilonewton. And you see this member is also in tension. And when we assume that the force are the forces in x direction, so we get negative force in member AB plus 4 kilonewton force plus force in BE member with its horizontal component force and angle 45. So we get the force in member AB, which is equal to minus 12 kilonewton. You see that the member AB is in compression. So when we take the joint F, so the forces that are acting in these four members um, are these forces. And the angle is about 63 degrees. You can find the angle by using sine theta, which is equal to basically you can use tan theta, which is equal to sine theta or cos theta. And you can find this angle by using. So if we take the force in y direction, so we get negative force FB and negative force AF with its vertical component sine 63, which is equal to 0. So we get force in the member AF, which is minus 20.10 kilonewton. And through this, we found that the member AF is in compression. And uh, by applying that, the forces in x direction, so we get negative F force in FG plus negative force in the member FE, negative force in the member AF with its horizontal component cos 63. So we get the force in the member FG, which is 21 kilonewton. And you see this member is in tension.